Alrighty, ladies and gents, here we see the classification of matter graphic again. And remember, chemistry is the study of matter and the changes that they undergo. We have already gone over our pure substances. Now we're going to go over our mixtures. So we are going to be looking at the difference between homogeneous and heterogeneous mixtures. So think back to biology class, okay? You had homozygous and heterozygous when it came to alleles. So this was your A, and your big A, where hetero was big A, little a. So homo means the same, hetero means different. And that's how we kind of classify our mixtures of substances. Okay, if it's not a pure substance, if it's not an element, it's not a compound, it's going to be a mixture. And that means that you are going to take two or more substances and put them together. That substance will have its own identity and their own properties and will differ depending on whether it is homogeneous and heterogeneous. Okay, so we're from Philly, so cheesesteaks, it's a way of life here. Fruit salad, the composition of steel, whether it be surgical or stainless, magnetic or not magnetic, the different types of lemonade, those are all different types of mixtures. Okay, so as we have already alluded, hetero means that there are going to be different parts that are going to be visible and seen through our mixtures, and homogeneous means it's going to be more homogeneous, which means it's going to be all throughout and consistent. All right, so heterogeneous is not uniform. That means it's going to be relatively easy to separate. If your friends get a pizza, you don't like pepperoni, you can take the pepperoni off. All right, you don't like cheese. There's some people that don't like cheese or are lactose intolerant, they take the cheese off. All right. Homogeneous is going to be uniform throughout. So that means it's all going to be the same and consistent. And it doesn't matter if you take a little bit off the top or a little bit off the bottom or in between, it's going to be pretty much consistent. Whereas if you take a sample of your pizza, this sample and this sample and this sample are all different. Okay, it's not uniform in the sampling. All right, salt water, soda, iced tea, brass, they are all called solutions. And solutions don't have to be liquid. Okay, this is a very big misconception. All right, there are solutions of air, so you can have gaseous solutions. Okay, there are solutions that are solid, like brass. That is going to be your copper and zinc mixture there. All right, so be careful. It's not just liquids. Yes, you can have a salt water solution, right? But that is only part of what the whole entire mixture is going to be. All right, so a pure substance has to have a specific makeup. It has to have the exact same characteristics in the exact same composition, no matter what. Okay, elements are easy. They're elemental, there's 118 of them. But there has to be a certain, let's call this recipe for an oxygen and hydrogen containing compound. All right, water will always be 11.2% hydrogen and 88% oxygen. Okay, that makes this substance water. You can also have H2O2. Well, that's hydrogen peroxide, and that is not going to be an 11.2% and 88.8% mixture. That's going to have a different percentage. So you can have different kinds of mixtures, carbon and oxygen. You have CO2. Those are two different things. This is a clear gas that is poisonous to us, and CO2 is kind of going to be a necessity of what we give off in our respiration. So if these are mixtures and we blend things together to get them, how do we go back and unmix them? Well, you have to use their physical properties. Okay, so it depends on the substance. It depends on the mixture. If there's two solids and they're just kind of like scattered throughout, well, then you just kind of use their physical properties like color or size or density, or if it's iron, okay, and sulfur here, you can take these two solids together from their property of magnetism. Okay, if there's two liquids, you can use something like evaporation. You can heat them up and they will boil at different temperatures. That's a specific process called distillation. You probably heard of like distilled water, distilled vinegar, maybe even distilled alcohol. It's a special system that goes through and uses the characteristic boiling points in order to separate things out. All right, so in my notes, I have this distillation apparatus right here. What you want to distill goes in this round bottom flask right here. It has a stopper at the top with a thermometer so that you can see what temperature you're at. Technically, this thermometer should be right here. This picture is a little bit lower than it needs to be. And it has this side valve that comes out. This goes into part number 2, which is a condenser, which is a tube within another tube that has cool water coming in and the warmer water coming out. And this flows up to the sink and actually empties in. In all the movies, it's a distillation apparatus that looks real cool and sciency and all that stuff. And most of the time when watching movies, it's set up wrong and it irks me. So if you ever make a movie, please ask me to be like a consultant. I'll come in one day, set it up, then leave, take a small fee, but it'll make people like me so much happier when we watch movies. So what happens? So when you are looking at your mixture, so say you have a mixture of water and you have a mixture of alcohol in here. All right, alcohol boils at 78 degrees Celsius, water boils at 100 degrees Celsius. When the Bunsen burner heats this up to 78 degrees Celsius, this alcohol will boil. It can't go anywhere, so it goes down the condenser. It's going to condense back into a liquid. So here it's a gas, here it's a liquid, here it's a liquid, and out comes the distillate, which is what you collect, and this will be purified. All right, and if something is doubled or triple distilled, this process just happens 2 or 3 times, and they remove any contaminants that wouldn't make it as pure. But it's a simple way to separate them out. Okay, in class, I do a little demo where I take grape Kool-Aid and I heat it up and I basically distill Kool-Aid and watch what happens. So you can see and check out that little video there also. Okay, so that is the difference between our mixtures of our homogeneous and our heterogeneous mixtures. It's a lot more difficult to remove and separate the homogeneous mixtures than it is for the heterogeneous ones.